In the previous examples, we performed the properties analysis of a pure component and a mixture in the properties environment. In this problem, we're going to start creating a simple process flowsheet in the simulation environment to mix and split the streams. Example 3. Mixing of liquid streams. 2 streams of water and ethanol mixture are mixed before splitting into 2 streams with the proportion of 0.4 and 0.6 respectively. Stream 1 contains 100 kmol per hour of 80% of water and 80% of ethanol at 100 degrees Celsius and 2 bar. Stream 2 contains 250 kmol per hour of 20% of water and 75% of ethanol at 60 degrees Celsius and 2 bar. The task is to find a flow rate, composition, temperature, and enthalpy of each stream. Since this is a liquid mixture, we're going to use an RTL as a property method. Next, as 2 streams are mixed together and then split into 2 streams, we will need a mixer to combine 2 feed streams of stream 1 and stream 2, and then a resulting product stream from the mixer will become a feed stream of the splitter, and then it's split into 2 product streams, namely stream 4 and 5. So let's return to ASPEN Plus with a new simulation case. With a new simulation, go to Setup and set the unit of measurement to med-C bar, since the temperature we use is degrees Celsius and the pressure is bar. Then click Next. It will navigate you to Components Specification Form. Again, add the components involved in the system, which are water and ethanol. Click Next. Then it will navigate you to Methods Specification Form. In the base method, choose an RTL. Then click Next. It will then lead you to Method and Parameters folder, also the Binary Interactions folder here. This is where the ASPEN Plus will automatically calculate the parameters for binary interaction between the selected components. Then click Next. The window Property Input Complete will pop up and ask you what you want to do next. You have several options available to choose, but we will choose the last one. Go to the simulation environment to create a flowsheet simulation. Then click OK. Now you are in the simulation environment in the main flowsheet window, where you can create a flowsheet simulation by adding blocks and streams. As you may remember that the first step to create the flowsheet is to add blocks. Since we have defined 2 unit operation models to be used, which are mixer and splitter, we will then go to the model palette and select mixer and splitter model category. For mixer, you can click the down arrow next to the icon to show the available submodel options. In this case, I will select the triangle icon. Click the icon, then your mouse pointer will be in an insert mode with the plus symbol. Left-click on the main flowsheet window to add the block, and then rename the block to Mixer. Then select the F-split model for splitter. Also choose the triangle icon either and add it to the flowsheet window. We will next perform the second step to connect the blocks via streams. Select the stream icon in the model palette. You will see that there are several stream types available to choose: material, heat, and work. Click the material stream and go to the main flowsheet. Here, the compatible ports of our blocks will appear. First, I will add the feed streams to the mixer by clicking at the red port, which is a required port. Now, the mouse pointer will be in connecting mode. Place the other end on the blank space and name the stream. Add another feed stream. Then add a stream to connect between mixer and splitter. For the splitter, hold your mouse cursor over the red port at the outlet of the splitter. You will see the description of the port saying that product required 2 or more if splitting material streams. This means that this port is the required port and also required at least 2 streams to connect. Click on the red port to add and name both 2 product streams. You can exit the insert mode by just click right, then the mouse pointer will turn to be the arrow. You can see that the flowsheet folder in the navigation pane has blue check mark. This means that the flowsheet definition has already been complete. At the bottom left of the screen, the status indicator shows as required input incomplete. If I delete, the flowsheet folder now turns to be the half red circle, and the status indicator is changed to flowsheet not complete. This means that the flowsheet connectivity is incomplete. Therefore, whenever you get the status indicator showing as flowsheet not complete, then you should carefully look at your blocks and stream connections. Then click Next. You can click Next at the Home ribbon tab, or click at the Quick Access toolbar. It will lead you to the next input required, which is the specification of the feed streams. For the S1 stream, in the mix sheet in input form, enter the operating conditions of the feed stream. Temperature is 100 degrees Celsius and pressure is 2 bar. Total flow rate as 100 kmol per hour. And in the composition field, select mole frac and then add 0.8 for water and 0.2 for ethanol. Then click Next. Complete the specification of the other feed stream. 60 degrees Celsius, 2 bar, 250 kilomole per hour with the mole fraction of 0.25 and 0.75 for ethanol. Then click Next. After that, we will go into the next step of specifying blocks. Now it leads you to the splitter input specification forms. You need to add the split fraction of the stream 4.4. Here, you need to add the split fraction just for only one stream. Then click Next. The window Require Input Complete will pop up. It says that all required input is complete. You can run the simulation now or enter more input. Okay, I'm going to run the simulation now. Click OK. Now the status indicators show that the results available. I'm going to check the result of the streams by clicking the Stream Summary here at the Home ribbon tab. Then the Results Summary Stream window will pop up. Here you can check the temperature of the product stream. Also, the molar enthalpy, mass enthalpy, composition of water and ethanol, and also the mole flows. Also mass flow or mass fraction.